Okay, this is section 4.8. We're starting with some complex numbers. Everything that we've had so far has had numbers underneath the square root that's positive, and now we're going to learn how to deal with what happens if we have a negative underneath the square root. Okay, so there's two objectives here we're going to look at. To identify and perform operations with complex numbers, and to find complex number solutions of quadratic equations. And this section is going to take this is probably going to take all week, so it's going to be about 4 or 5 different lessons that we're going to go through on this. Okay, so some of the things I'm going to explain at this beginning part is going to involve today, some of it's going to involve tomorrow, some of it may not involve until a couple days later. Okay, so a couple definitions that I think are very key as we look at complex numbers. Okay, and the imaginary number is the first definition here that we want to look at. Imaginary number. Okay, it is any number in the form of a plus b times I, where b cannot be 0, and a and b are real numbers. Now you'll notice you see the letter I in there, and we're going to talk about I here in a little bit more of what it really means. Okay, I is what we stand for. We use to stand for what we call an imaginary number. Okay, a complex number is the combination. Complex number here is the combination of a real number and an imaginary number put together. Okay, so anytime we have a real number put together with an imaginary number, that's what we call a complex number. Okay, now complex conjugates take two things that are essentially the opposites, but they're not really opposites. They're number pairs of a plus bi and a minus bi. Okay, and what you'll notice is as you look at these two things, these two expressions, the opposite part is the imaginary part, and the real number is always the same. Okay, and again, complex conjugates we're going to get into when we start using division. When we do some multiplication stuff, we'll look at those as well. Okay. All right, so let's take a look down here at the essential understanding here. The complex numbers are based on a number whose square is -1. Now, it says the imaginary unit is the complex number whose square is -1. So if we said I squared is equal to -1, okay, if I squared is equal to -1, how would I solve that equation? Okay, and what you would do is you would take the square root of each side, and if you took the square root of each side, you would get I equal to the square root of -1. So essentially what that is saying is we're going to take any number that is negative underneath the square root, and we're going to say, okay, well, we can't really find that value, so we're going to put a letter to it. We're going to say that that's worth I. So I has a value of the square root of -1. That's going to help alleviate any problems we have with negatives underneath the square root. Okay, so as we look at going through and solving these problems and simplifying these problems, we're going to use the square root of a negative real number. Okay, for example, if I had the square root of -a, okay, and what I want to do here is I want to try and get -1 out of there so that it's easier so that I have a positive number. So if you'll notice, they take this -a and they split it up into -1 times a. Okay, well if you do that, you can take and split that up into 2 different roots. And now you'll notice as you look at this a here that a is now positive, and we don't have a negative underneath the square root anymore. Well, we said earlier that I is the square root of -1, so we can say that we have I times the square root of a. Okay, so we're going to look at some examples down here on the bottom. Okay, and go through a couple of these to kind of give you an idea of how these are going to look. Okay, so it says simplify the number using the imaginary I. Okay, imaginary number I. So as you look at this, again, we don't know what the square root of -2 is. We don't actually have an amount to that right now. So what I'm going to do now is I want to break -2 into a different number. So I'm going to take and break -2 into a multiplication problem, and I'm going to say that that's -1 times 2. Okay, and by doing that, I can break up these square roots. This is the square root of -1 times the square root of 2. And we said earlier the square root of -1 was I. So I'm going to get rid of that square root of negative 1, and I'm going to replace it with the letter I. And we're going to take that times the square root of 2. And now we've simplified that root to where it does not have a negative underneath of it. That's the whole point of having the concept of I. Okay? So let's take a look at example 2 here. So if I break this guy apart again, I've got the square root of negative 1 times 7, which gives me the square root of negative 1 times the square root of 7. And the square root of negative 1 is I. The square root of 7, I can't break down. There's no perfect squares that go into it, so I finally come up with an answer of I times the square root of 7. And again, you'll see it alleviates the negative underneath the square root. Okay. Now you'll notice that the first two problems I gave you were prime numbers, which is great because you don't have anything to break down. But number 3 is a little bit different. So again, I'm going to break this guy apart into negative 1 times 18. Okay? So, as I look at this, this is the square root of negative 1 times the square root of 18. Square root of negative 1 is I times the square root of 18. There's only one problem, though. 18 has a perfect square in it, so I still have to break that down as well. So now I have I times the square root. The biggest perfect square that will go into 18 is 9 times 2. So now I have I times the square root of 9 times the square root of 2. What is the square root of 9? It's 3. So I'm going to move this 3 out front, make it 3 times I times the square root of 2. Okay. Anytime you have I and a number, you're going to treat I just like a variable. It's always going to go behind the number. Okay. All right, let's take a look at example number 4. Again, break this down into the square root of negative 1 times 25. So this is the square root of negative 1 times the square root of 25. Square root of negative 1 is I. Square root of 25 happens to be a perfect square, which is 5. So my final answer, again, anytime we have a number, always goes in front just like you would put a variable. Okay? So you're going to have to be able to break down some square roots with negative numbers in them. Okay? That's going to be part of your homework here as well. All right? Okay, let's take a look at the... Okay, next key concept deals with what we call complex numbers. Okay? And you can write a complex number in the form of what we call a plus bi, where a and b are real numbers. Okay, remember, I stands for an imaginary number. Okay, if b is equal to 0, the number a plus bi is a real number. So if b is 0, then you don't have an imaginary part and it's just a real number. Okay, if a equals 0 and b is not 0, the number a plus bi is what we call a pure imaginary number. So if a is 0, you would have just b times I, which means that it's pure imaginary. That means there's only imaginary numbers in there. Okay, but a complex number is when you take a real and an imaginary and put them together. Now, a couple things about this that you got to make sure you understand. These are not like terms. Okay, you cannot add or subtract them. Okay, they're not like terms. I is just like a variable. Okay, so if I had like 5 plus 3i, I cannot make that 8i. They're two different terms. They're not like things. Okay. All right, now the main part of today's lesson is going to be the next part, which is adding and subtracting. We're not going to worry about the absolute value, the number plane, any of that stuff for right now. We'll come back to that later when we start talking about graphing stuff. But the main part that I want to talk about in this section is adding and subtracting complex numbers. Okay, so we've got really 4 steps that we're going to look at doing. All right, so number 1, the first step says you're going to add or subtract the real parts of the expression. So you're going to take the real numbers and combine them together, add or subtract. Then you're going to take the imaginary numbers and you're going to add and subtract those. Okay. Finally, the real and imaginary parts are not like terms. Again, don't forget those, so you cannot add those together. So your answer is going to be... Your answer is going to be in the form of a real number plus an imaginary number. Okay? one thing about subtraction that you really have to pay attention to, and this is really important, is that you must distribute the negative first, then subtract. If you don't distribute that negative first, you're going to get every single subtraction problem wrong. Okay? Now, let's take a look at some examples here. Okay, so we've got some examples here, and let's take a look at adding and subtracting. Okay? The first three that we have, 1, 2, and 3, are all addition. The second three are subtraction. Okay? So again, what we're going to do here as we look at these problems is I'm going to take the real parts and the imaginary parts and put them together. So the real parts here, this is 4 is real and negative 4 is real. Okay? So I'm going to put them together. I've got 4 and negative 4 plus. I've got negative 3i and positive 3i. Those are the imaginary parts. So essentially, when you're adding and subtracting, it's really just like a variable there. I mean, it's really no different. So positive 4, negative 4 is 0. And negative 3i and positive 3i is 0i. So if I have 0 plus 0i, how much do I have total? I have 0. And you're done. Okay, number 2. Again, I'm going to put the parts that I have that are real together, 7 and negative 3, plus 2i and an I together. And 7 minus 3 is 4, and 2i plus another I is 3i. Again, you cannot add these things together. Okay, this is not 7i. It's 4 plus 3i. They're different terms. They're not like terms. Okay? All right, let's take a look at number 3. As we look at number 3, again, I'm going to take my terms that are the same. I've got my real parts, negative 3 and positive 3, and 9i and 9i. Negative 3 and positive 3 is 0. 9i and 9i is 18i. So really, I don't have a real part, so this is just 18i. And this right here is just a pure imaginary number. There's only an imaginary number with it. Okay? All right, so those were 3 addition examples. Again, it's pretty straightforward, pretty simple, not too bad. Now, subtraction, again, don't forget, when you have subtraction, you have to distribute the negative first. So I've got to take this negative in the middle and distribute it to everything behind it. And what it's going to do is it's going to change the signs of everything. So these two up front are not going to change. 5 minus 3i. The opposite of negative 2 is positive 2. The opposite of positive 4i is negative 4i. All it does is changes the signs on everything. Okay? So now I take my like terms. I've got 5 and positive 2. That's 7. And I've got negative 3i and negative 4i, and that is negative 7i. And again, I cannot do anything else because these are not like terms. Okay? Number 5. Again, first thing I got to do, I recognize I see that negative sign in the middle. I got to distribute that negative. So now I have 8 plus 6i. The first parentheses doesn't change. Minus 8 and plus 6i. Okay. So now again, I add my like terms here. 8 and negative 8 is 0. And 6i and 6i is 12i. And I don't have a real part, so my answer here is just 12i. Okay. All right, number 6. You'll notice number 6 is just a little bit slightly different. You notice you don't have any i's, but you do have some square roots with negatives. So what I need to do is I need to change my square roots with negatives to imaginary numbers. So when I do that, here I get negative 2 plus the square root of negative 9. The square root of 9 is 3, and the negative makes this 3i. Okay? Again, square root of negative 9 is the square root of negative 1 times 9, which is the square root of negative 1 times square root of 9. Square root of 9 is 3. Square root of negative 1 is I. Okay? Minus negative 1 minus, in this case, the square root of negative 36 is 6i. First thing I got to do here, once I do that, is distribute. So I have negative 2 plus 3i. Negative, the opposite of negative 1 is positive 1. The opposite of negative 6 is positive 6i. And now I combine my like terms. Negative 2 and positive 1 is negative 1. And positive 3i and positive 6i is positive 9i. And again, I cannot combine those because those are not like terms. Okay, so in this section we're able to simplify roots with negatives underneath, and then we added and subtracted imaginary numbers and complex numbers. Okay? Again, it's not too complicated. You're going to find out that as we look at these imaginary numbers, they're not too bad. Okay, this concludes section 4.8, complex numbers, adding and subtracting.